Hi everyone. Today we explain relations as a function. What is a relation and function? To do this, let's bring to you an example. Four students, Ashley, Pamela, Vilma, and Camelia, are given a math test, which is marked out of 5. Their marks for the test are respectively 5, 4, 5, and 3. We can represent this data as ordered pair in the form x, y, where first element or first coordinate is the name of the student, which node by x, and second coordinate or second element is the mark that relate to the name of student, which denote by y. In this way, we obtain this set of ordered pairs. Ashley 5, Pamela 4, Vilma 5, Camelia 3. This set of ordered pairs is a relation. Definition. Relation is called any set of ordered pairs xy. The set of all first coordinates, first numbers x in the ordered pairs is called the domain of the relation. The set of all second numbers, second coordinates y in the ordered pairs is called the range of the relation. Example, find the domain and the range of the relation, which is represented by the set of ordered pair 2, -5, 1, 4, -3, 7, 0, 3, 9, 17. Solution. Domain is the set of the numbers consist of 2, 1, -3, 0, 9. Range is the set of second coordinates, which is consist of the set of numbers -5, 4, 7, 3, 17. A relation may consist of a finite number of ordered pairs or infinite numbers of ordered pairs. Form to represent relations. Relations may be represented, defined in several ways, as arrow diagram or correspondence, as a set of ordered pairs, as a graph, and as a table. Express the relation given as a set of ordered pairs -2, 5, -1, 4, 1, 3, 2, 4 as a table, as an arrow diagram, and as a graph, as we have represented in these slides. Form to represent the relation. Another example to represent the relation by mapping, by set of ordered pair, by table, and the graph. Domain and the range of a relation. Give the domain and range of each relation. Are given two relations by the graph, and we want to find domain and the range. At the graph on figure A, domain consists of the numbers -1, 0, 1, 4, and range consists of number 1, -1, -3, and 2. This is set of the second coordinate. And the graph of relation in figure B have the domain, the set of numbers -2, -3, 0, 2, and the range consists of the numbers 0, 2, and 3. Function. What is the function? A function is a special kind of the relation which takes one element of one set and assigns, relates to it one and only one element of the second set. The first set is said to be the domain of the function, and the second set is the codomain. We say that each element of the first set is mapped onto its image in the second set. The set of all images will be a subset of the codomain and is called the range. Thus, in the above example of relation of four students and their marks for the math test obtained, the domain is Ashley, Pamela, Vilma, Camelia. The codomain is the set of all possible marks 1, 2, 3, 4, 5. The range is consists of the marks 5, 4, and 3. Function. A function is a special type of relation in which each element of the domain is paired with exactly one element from the range. Here we have represented two functions by the diagram, arrow diagram. Function. Definition of function. A function is a relation in which, for each value of the first coordinate, which we called independent variable of the ordered pairs, there is exactly one value of the second coordinate, which we called dependent variable. So a function is a special type of a relation that pairs each domain value with exactly one range value. That is, at the function, each preimage has one and only one image. In a function not two ordered pair, not two ordered pairs have the same first coordinate and different second coordinate. For example, if the relation has the ordered pairs 3, -5 and 3, 2, it is not the function because the first coordinate are the same and the second coordinate of ordered pair are different. A function can map more than one element of the domain onto the same element of the range. For example, Ashley corresponds to 5, Vilma corresponds to 5. Such functions are said to be many to one. Function for which each element of the domain is mapped onto a different element of the range are said to be one to one. What's not a function? A function is a relation in which no two ordered pairs have the same x value and different y value. So the relation consists of the set of ordered pair -3, 2, 4, 5, 6, -1, 4, 2. It is not a function because first number are same and the second number 5 and 2 are different. One-to-one and many-to-one function. Relationship which are one-to-many and many-to-many can occur, but from definition above, they are not functions. The following diagram illustrates these facts: one-to-one, many-to-one, and one-to-many. How to represent a function? Since relations and function are sets of ordered pairs, we can represent them using a correspondence or mapping, tables, sets of ordered pairs, and graphs. In addition to these forms, we can describe a function using a ruler that tells how to determine the second variable y for a specific value of the first variable x of ordered pair xy. Suppose a function has the set x as the domain and is such that it triples any element x of the domain to give the corresponding element of the range. This function would be written as f of x corresponds to 3x, or f of x equals 3x. As this function would map the number 5 onto its image, the number 15, we could write this fact as f5 corresponding to 15, or f of 5 equals 3 times 5, 15. The ruler may be given in words. For instance, the dependent variable is triples the independent variable. Usually the ruler is an equation. Dependent variable y is equal 3 times independent variable x. When a function is defined with a ruler or equation, we say y is a function of x. We use the notation y equal f of x called function notation and read f of x as f of x or f at x. So f of x is just another name for the dependent variable y. The names of functions are often given by either lowercase letter or uppercase letter, such as f, g, h, p, l, q, k, etc. Represent of function. Represent function f consists of ordered pair, set of ordered pair 1, 2, -2, 4, 3, -1, using arrow diagram, table, and graph, as we have represented in this slide. Function machine. Another way to think of a function relationship is to think of the independent variable as an input and the dependent variable as an output. That is, it is helpful to think of function as a machine, a box of numbers. The domain is put into the machine. The machine then alters each numbers according to the sum rule and output the new numbers into a second box, which is the range, as we represented here in the slide. Function machine. This is illustrated by the input-output function machine for the function defined by y equal to x. As you see in the figure here, input is number 4, put in the machine, and in base of the ruler y equal to x, we obtain output of number 8. This is the function machine idea. Example 1. If f of x for x minus 4, g of x equal x squared minus 1, for domain of all x, find f of 1, f of negative 2, g of negative 3, g of 5, and e, the possible value of m, if f of m equals g of m. Solution. F of 1. We want to find f of 1. To do this, we substitute in place of x number 1 at the function f of x, and we have f of 1 equal 4 times 1 minus 4 equals 0. F of 2. To find f of 2, x is equal to negative 2. For this reason, we plug in or substitute in place of x at the function f of x number negative 2, and we have 4 times negative 2 minus 4 equal negative 8 minus 4 equal negative 12. G of negative 3. This means that to find g of negative 3, x equal negative 3. For this reason, we substitute or plug in place of x at the function g of x number negative 3. So we have g of negative 3 equal negative 3 in place of x raised to second power minus 1 equal 9 minus 1 equal 8. D, g of 5 equal 5 square minus 1 equal 24. F of m, let's find f of m. That means that in place of x at the function f of x, we substitute number m, and we have f of m equal 4m minus 4. And g of m, we substitute or plug in place of x at the function g of x number m, and we obtain g of m equal m squared minus 1. Thus, if f of m equal g of m, we have 4m minus 4 equal m squared minus 1. This is quadratic equation. To write in standard form this quadratic equation, we collect all term one side and 0 on other side, and we obtain m squared minus 4m plus 3 equals 0. To solve this equation, let's solve by factoring. Factoring this quadratic equation and obtain m minus 3 times a minus 4 equals 0. In base of 0 factor property, we have m equal 3 or m equal 1. Example 2. Is this relation a function? Explain. As you see in diagram, domain consists of numbers 0, 1, 2, 3, and range consists of set of numbers 4, 5, 6, 7. There is one range value for each domain value. This relation is a function. Example 3. Give the domain and range of each relation. Tell whether the relation is a function and explain. Relation A consists of set of ordered pair 8, 2, negative 4, 1, negative 6, 2, 1, 9. Domain of this relation consists of the number negative 6, negative 4, 1, and 8. And range consists of set of this number 1, 2, and 9. The relation A is a function. Each domain value is paired with exactly one range value. For this reason, it is a function. Relation B. Domain consists of set of numbers 2, 3, and 4. Range consists of set of numbers negative 5, negative 4, negative 3. The relation is not a function. The domain value 2 is paired with both negative 5 and negative 4. So the domain value 2 is not paired with exactly one range value, but is paired with two. For this reason, this relation is not function. Domain of the function. If the domain of a function is not stated, it should be assumed to be the set of all real numbers x that when substituted into the function produce a real number, give a real number, that is, for which the function is defined. Example, find the domain of the function f of x equal 3x plus 2 over 4x minus 12. The domain of this function consists of all real number, excluded only value of x that make denominator 0. Which are those values? To do this, set denominator 0 for x minus 12 equals 0, x equals 3. Domain of this function is set of all real numbers, excluded value x equals 3 that make denominator 0. We write domain as set builder notation. D equal, domain equal, set of all real number x such that x not equal to 3. Or interval notation, interval negative infinite 3, union 3, infinite. Restriction on domain. No zero in domain, no zero in denominator, no negative in square root. G of x equal 3x plus 5 over x squared minus 4x minus 5. To find the domain of this function g of x, we need to find the value of x that make denominator 0. For this reason, we set denominator x squared minus 4x minus 5 equals 0. This is quadratic equation. Solve it by factoring method. Factoring it and obtain x minus 5 times x plus 1 equals 0. From the zero factor property, we have x minus 0 equals 0, x minus 5 equals 0, and x plus 1 equals 0. From the first linear equation, obtain x equals 5, and from the second, obtain x equals negative 1. So domain of this g of x function are all real numbers, excluded number 5 and negative 1. We can write the domain of this function as interval notation in this form. Interval negative infinite negative 1, union negative 1 5, union 5 infinite. H of x equals square root of 2x minus 5. You know that the square root of negative number does not exist in the real number set. For this reason, we set the restriction 2x minus 5 must to be greater than or equal to 0. This is linear inequality. Solve this linear inequality and obtain x greater than or equal 5 over 2. So domain of this function consists of all real number equal 5 over 2 or greater than 5 over 2, which can represent as interval notation 5 over 2 infinite, where at 5 over 2 put the break because 5 over 2 included in the domain. Domain and range of a function. The entire graph of the function f is shown in the figure below. Write the domain and range of f using interval notation. Solution. Domain is the interval negative 8, 7, where negative 8 included. For this reason, we use bracket, and 7 does not include it. We use parentheses for endpoints of the interval that do not include it, and break for endpoints of the interval that include it. Number 7 does not include it in the domain because the endpoint of the graph is open circle. Range is the interval negative 5, 6. 6 included because, as you see, the endpoint of the graph here is the closed circle, not open circle. For this reason, we use the bracket as endpoint of the interval. Domain and range. Give the domain and range of a relation in figure A. Tell whether the relation is a function. Explain. Domain consists of all first coordinate. So the domain consists of set of number negative 1, 0, 4, 1. And range consists of set of all second coordinate. So the range consists of the numbers. Set of the numbers 1, negative 3, and 2. This relation is a function because each domain value is paired with exactly one range value. Relation and the function. Give the domain and range of the relation. Tell whether the relation is a function. Explain. Use the arrow to determine which domain value corresponds to each range value. And as we see, domain consists of set of the numbers -4, -8, 4, 5, and the range consists of number 2, 1. This relation is a function. Each domain value is paired with exactly one range value. Determine the graphic whether it is the graph of a function. Vertical line test. To determine the graphic whether it is the graph of a function, we use vertical line test. If each vertical line intersects a graph in at most one point, then the graph is that of a function. So the graph in figure A intersects by each vertical line at most one point. For this reason, this graph represents graph of a function. The graph on figure B, as you see, each vertical line intersects a graph more than one point. For this reason, this graph, it is not graph of a function. Graphically, vertical line test. We use the vertical line test to determine if a given graph is graph of function or not. If any vertical line intersects a graph in more than one point, the graph does not define y as a function of x. First graph is a function, the second is not, because each vertical line at the first graph intersects graph at one and only one point, at no more than one point. For this reason, is the graph of a function. At the second figure, each vertical line intersects a graph in more than one point. For this reason, this graph, it is not graph of a function. Represent relation and function. Vertical line test. The relation is a function if no vertical line touches the graph at more than one point. Is it a function? Yes, the first is a function in base of vertical line test, and the second is not a function in base of vertical line test.